Okay, well, welcome back for part two of this lecture series. So let's go ahead and continue on with our next tests, which are the tests found in the triangle calculator test. Now, these have been split up in a different way than what I would normally do, because I'm trying to give this to you piecemeal. What I've done is in the triangle, I've created two methods. I have one that actually returns a value at a specific row column, and then I have one that actually does a print. Well, in a real implementation that you're writing, the print is really the only thing that you're going to care about. However, to go ahead and try to simplify this, or at least show you how you can have tests around a couple of these different things, I have added both of these, okay, or exposed both of these, which means you can test get value at by itself. However, in the future, this should be hidden and just an internal part of your application, right? And you should only write tests that hit directly against print triangle itself. All right. So let's go back to our test, right? And we'll actually go to the implementation so I can quickly control tab between those. And here's my first one. Get value at should throw argument out of range exception when row is negative. Okay. It's actually a pretty simple one. I already have the expected exception up here. And what we can do is we can actually do our test calculator, which I have created for us each time using this setup dependencies method up here. Notice it has the setup attribute, which will be run one time before each test to make sure that I have a new object with a new mock that's all clean and doesn't have any artifacts from previous tests that could give it issues. So we'll go ahead and do get value at, right? And our row is going to be -1 because I want it to be negative. And then I'm going to use a little bit of a trick here. I'm actually going to go ahead and use the arg int is anything. And the main reason I do this is I know for this test right now it is going to be ignored. And I think that the wordage around arg int is anything is very clear to let them know that I don't care what value is used here, and that whatever value put in there should not affect the results of this test. So, if we go ahead and save this and run it, okay, we're going to find that, guess what? We get a not implemented exception. Now, this exists because of two things inside of the triangle calculator. The first is my constructor throws this. Well, let's go ahead and get rid of that because I don't want my constructor to be throwing that exception right now. And to fulfill this one should say if row is less than 0, right, then I am going to throw new argument out of range exception. Okay? And in this case, the param is going to be row. Row cannot be negative. Okay? So if we come back here and we rerun this test, we should see a successful execution. Okay? Next test is very similar. This one is saying that when the column is negative, okay, so I'll say test calculator dot get value at arg int is dot anything, and we'll say -1 for the column. Right, and now if we actually go back here and we rerun this, we see that the wrong type of exception was thrown, which is fine. So we need to come in here and say if row is less than 0, we also want to go ahead and say if column is less than 0, right? We will also throw a new argument out of range exception for a column. Okay. And we'll save it. And now we will go ahead and run this test. Okay. And we can see that one is now also successful. Now, one thing about this, because we have two tests at work, I don't like this code duplication, since if either of these are below 0, I want to go ahead and throw an argument out of range exception. So what I'm going to do is I'm going to refactor this, okay? And I'm specifically going to say if this is, or if my column is less than 0, okay, then I'm going to throw this exception, and I'm going to say row neither row nor column can be negative. Okay, and this is complaining because it's not actually a symbol in part of the argument exception, but I'm okay with that for right now. So if we go ahead, we can remove this, and if we come back to our code just to make sure this worked, we go through both of these, and we see they are both successful. So that's where the refactor part of this comes into play. Right, so our next one should say that we should throw an out of range exception when the column is greater than the row. Okay, and this is just one of the things about Pascal's triangle, is that you will always have the number of columns for the row that you're on. So if you have more columns than the row that you're on, there are no values in there, and we should throw an exception. So in this case, I'll say test calculator, get value at, and I'm going to create a temporary value here for row, which can be equal to 1. Oh, I don't know why it's doing that, but that's okay. And we'll say get value at row, and then row plus 1. Okay, so our column is actually larger than what our row is. Now if we run this right now, it should fail. Okay, and we'll go ahead and come back into our code, and we can actually say, oops, if column is greater than row, then we will go ahead and throw a new argument out of range exception. Right, and I'm just going to take this message off since that squiggly line's kind of annoying. Now if we come back here, rerun this test, and we can find that that's also successful. And again, I'm going to come back to my triangle code here, and I will refactor it. So I'm saying if either of these are less than 0, right, or column is greater than row, and we will throw this. Now, whether or not you want to keep them as separate if statements is totally up to you. This can be a little bit confusing, specifically how it's a sub query as well as another one. But I will leave that up to you. Personally, I don't really care for this style, but I'm trying to get the or have the get value at method as small as possible. Okay, so let's go ahead and go up with our next test here, or actually go back to our test and verify that we didn't break anything with our change. Right. So we can run that, and in fact, let's just go and select all 3 of these and run all those again, and we see they are all successful, so we are good. Okay, now we're on to the first one that should not throw an exception. We're expecting that when a column is 0 and row is 0, that we should get a return value of 1. Pretty straightforward. So we'll go ahead and run this right now. Actually, I've got to add the method first, so we'll say constant expected is equal 1. And then we'll do, as our test calculator, get value at our row of 0 and our column of 0. Right, and then we'll just assert they are equal. Right, row 0, col 0 should result in 1. Let's go ahead and save it, and we will run this test, which should fail for us. Okay, so our test failed, so now let's go ahead and add an implementation to that. So we're saying here that if our row is equal to our column, right, that we can go ahead and return 1. And actually, that's not explicitly what it's saying. We're saying that if row is 0 and column is 0. So we actually could change this to be if row is equal to 0 and column is equal to 0, then we can return our value. So let's rerun this test. Oh, why didn't it build? What did I forget? That's column. Right. Good. All right, let's go on to the next one, which says it returns 1 when the column is the same value as a row. Okay. Now that is a different one, but is also a good one. So let's go ahead and say expected is equal to 1. And I don't know why this completion is happening for my number 1. It's driving me nuts. So I'm going to have to watch that. Actual is my test calculator, get value at. And this time I'm going to go ahead and create a constant row is equal to 2. Right? And I can say row and row for both of these so that they're the same. Assert are equal my expected, my actual, okay. Give it a message. Let's go ahead and run this test. And that one's going to fail. So we can come in here, change this to say if row is equal to column, right? Then we will go ahead and return 1. And if we go ahead and run this, huzzah, we are successful. On to the next one. And this is saying that whenever the column is 0, we should get a value of 1. Okay. Uh, 1. And let's do int actual equals test calculator get value. I'm going to make our row 2 and our column 0. And we'll assert they are equal. Right? Expected, actual. Okay. So, before I switch, let's go ahead and run this test, which should fail. Yep. Okay, good. So if we come back here, we can go ahead and add that other thing that says if column is equal to 0, then we can go ahead and return 1. Okay, so we can go ahead and run this test. Good. Now you'll notice in our code there's certain refactoring that we need to do. First off, we have this statement here that says if row is equal and column is equal to 0, but we also have this that says if the column by itself is 0, regardless of the row, we should return 1. This should be enough to fulfill our other execution. So let's go ahead and do this and delete it, right? And we can go ahead and rerun this test to make sure that we didn't break anything. But then let's go ahead and rerun all of our tests because we just did a refactor, so let's make sure we didn't introduce a bug. If we didn't, we're good. Okay? I'm going to do one other refactor, and that is I'm going to go ahead and pull this same statement up here. It says if the column 0 or my row is equal to my column, right, I'm going to return 1. Again, another refactor. Come back to our code. We'll rerun this guy. Okay, he succeeds, so now we can go ahead and rerun all these. And we see that we are successful again. We're at a great place. We can go ahead and continue on with these. Okay, there's one more specific one that I haven't implemented, and that is that when I'm given a 1 and 3, that my result should be 3. Okay, so we'll say const int expected is equal to 3, const int row is equal to 3, and const int column is equal to 1. Right? And we'll do int actual is our test calculator, get value at, our row, and our column. And we can assert that that is correct. For row 3, column 1 should be 3. Okay. And if we run this, we'll see that it would fail. Okay. And so now let's go ahead and go into our code to make this work. Now there are those purist TDD people that will say, well great, we have to put in here explicitly if row is equal to whatever and columns equal to whatever. I don't like that. I know what I'm trying to do here is get to the meat of my actual logic, so at this point I'm going to give it my logic. And at this point the logic for this method is to go ahead and return the appropriate pre-calculations for what we had before. Now the actual algorithm to complete this is that we're going to sum up the two values right above it in the triangle. So we're going to return, and I'm doing this recursively because I like recursion. We'll get the value at the row, so when the row is going, or it'll be row minus 1, and then the same column, plus get value at row minus 1 and column minus 1. Right, so you're getting the column and the row that are directly above it. So we can come back here, and let's rerun our test to make sure that works. And lo and behold, we are successful. Okay, so this is the second part. I'll go ahead and let you add any other extra tests that we have here to make sure that all values are the same. A couple I would look at is row 5, column 1. Okay, because if you're on row 5, column 1, the value you should be looking for is found on a Pascal's triangle that you could Google search. I would just do probably 1 to maybe 2 other values just to verify that the algorithm is correct. After that, go ahead and come back and let's move on to